which shows the full life cycle of a single AS2 message. The left side of the diagram shows what are the AS2 processing steps done by the sending partner of the AS2 message. The right side of the diagram shows what are the AS2 processing steps done by the partner who has received this AS2 message. So first of all, the sending partner will have a file or a file content. They need to share our AS2 protocol to the receiving partner. As the first step, they will calculate a digest of this file using an algorithm such as SHA-1 or SHA-256 or MD5. And this digest is called MIC, or the message integrity check, in the AS2 protocol. Once this value was calculated, the sending partner will store this value on their system in a database or some other storage mechanism for future use. Secondly, they will sign this message with their own private key. An algorithm such as SHA-1 with RSA or SHA-256 with RSA can be used to do this or add this signature. Finally, they will encrypt this message payload using the recipient's public key. An algorithm such as 3DES or AES-128, AES-256 can be used as the encryption algorithm here. Once these processing steps are done, the sender will send this message over an HTTP channel to the receiver's AS2 system. When they are sending this message, they will include certain HTTP headers mandated by the AS2 protocol, which are generally called as AS2 headers. These AS2 headers will contain important information for the receiver to successfully process this message. For example, these headers will contain the AS2 identifier of the sending party, AS2 identifier of the intended receiver, a unique message ID for this file, and some other details about the algorithms used for the encryption, signing, and MIC calculation. Also, some parameters related to MDN signing. So once this message was received with these headers on the receiver system, the receiver can first use these headers to do some primary validations on their side. For example, they can check the sender's AS2 ID and verify that the sender is someone or some party they know. Also, they can check the receiver's AS2 ID and see whether this message was actually intended for them. Also, they can also check the message identifier and see whether this is a completely new message or a duplicate of a message they have already processed. Once these primary validations are done and passed, the receiver will try to decrypt the message payload using their own private key. Then, if that was successful, they will get the signature from the message and try to verify it using the sender's public key, which they exchanged earlier during the AS2 setup. Then they will also calculate the digest of the decrypted file using the same algorithm used by the sender in the first step. This is also called the MIC. And finally, they will create something called MDN, message disposition notification, which will have this MIC value included. This MDN is kind of like a signed receipt to acknowledge the sender that I have received this message at this time with this ID, and this is my processing state. So then this MDN will be sent back to the sending party. And once the sending party receives this MDN, they will first persist it on their systems as a proof of successful delivery. Then they will extract the MIC from that MDN and compare that MIC with their own value they calculated on the first step to see whether these MIC values matches with each other. Once that step is done, the lifecycle of the AS2 message gets completed.
Exchange your AS2 messages with MFT Gateway. Sign up for the 30-day free trial.